In this demo, I'll be showing our setup that utilizes the RAG technique to enable a user to ask natural language questions to their system and then get back natural language answers. Our architectural diagram is shown here, and as you can see, we have a couple of components that are integrated together. In the top left corner, we have our clinical users that are using a system called OpenELIS, and this is a lab management system. Now, this system has a Fire API that we are utilizing with a tool from Google called Google Open Health Stack. And this is more of a data pipeline that we can run using Fire to flatten the data from the lab system into an Apache Spark database. And so we end up with tables and also some flattened views that we are going to utilize. In the middle here, we have our main component that's going to help us with our RAG. And as you can see the flow in the bottom left corner, we have a user who we are calling the AI user. He or she will ask a natural language question, and this is going to be sent to this main component. The answer is going to be generated in two steps. And so in the first step is to change the natural language question into an SQL query that we're going to use to run against our database. So once we get the query or the question from the user, this question is going to be sent to a cloud large language model like ChatGPT or Gemini and or any other that you might have configured. And what happens here is that the component is able to generate a system prompt that is able to tell the LLM how it should answer the question asked by the user. So the cloud LLM will respond to us with an SQL query, which of course we need to validate and ensure that it's not going to do anything like altering the database. After validation, we run then that query against our Apache Spark database, and the result set that we get now undergoes the second step, which is transforming the result set we've got into a natural language answer. Now, this is done in this step 2. However, the difference from this and step 1 is instead of using a cloud LLM, we instead use a local LLM. And this is because of privacy and avoiding exposing our private data to a cloud model. So the local language model is given the result set and asked to convert it into a natural language answer. After generating that, it then sends it back to the AI user, and so they'll have the narrative answer and also show to the user the SQL that was actually run. Now, to just illustrate the systems I've talked about, I'll just navigate to them. So here we have our lab management system called OpenELIS, where users will be entering data in their laboratories, say orders and patients that they're going to be getting. Now we've mentioned the Google Open Health Stack pipeline, which you can see here, and this is able to run micro batching or a full batch to flatten the data from OpenELIS, which is Fire-raised, into our Spark database. To look at our Spark database that is flattened, we can see here a couple of views that have actually been flattened out. And if you look on the right here, we have the patients that are flattened out, having all the information in one place. We also have the service requests, the equivalent of the lab orders, also flattened out. So we can see almost all the information that we need. The reason for this flattening out is to enable the generation of the SQL query not to have so many joins or to reduce on the complexity that would come with having multiple tables. Now we come to the main component that we've just talked about, and for now we're just calling it a RAG SQL assistant. So I'm going to demonstrate how the user will interact with this application and be able to generate natural language answers. So I'll start with the first question to ask the system. I'll just ask it, how many patients are in the database? So it will go through the process that I've just mentioned. And part of the reason that it's slow right now is because of the local large language model that we are using. Because of the resources we need, it tends to be slow sometimes. But we shall give it a couple of minutes. Okay, so we have our answer, and as you can see, it has responded by telling us how many patients it has in the database. And if you scroll down, we have also the logs that clearly show you the query that was actually run. And as you can notice here, it has actually used our flattened table. So I'll now ask other questions to just show you what I mean. So as you can see, the system has been able to answer our questions as we've asked it. So it has given us the number of patients in the system, given us the names of the practitioners or the practitioner with the most orders, and also the names of patients that are below 18 years. So pardon some of these names, they randomly created in the system. But as we can see, down here, we also have the queries that have actually been run that clearly show us what went on, or the queries that were generated by the cloud large language model, and then the answers that we gave to the local large language model, and finally the results as they are presented to us. Thank you.